So we are dealing with the 13th problem in this series, and the problem number is 3.13. The problem is stating a thin straight rod of length 2a carrying a uniformly distributed charge q is located in vacuum. Find the magnitude of the electric field strength as a function of the distance r from the rod center along the straight line. In the first part it is asking perpendicular to the rod and passing through its center, and in the second part coinciding with the rod's direction at the points lying outside the rod, and the problem is also asking us to investigate the obtained expression for r greater than a. So if we begin this problem, we begin with the first part. So in the first part we begin by constructing a charged line wire. So this is the charged thin straight rod. The length of this rod is specified as 2a, and it is having positive charge is spread uniformly over its length, and the separation is 2a. Perpendicular to the length, over here we are asked to calculate electric field which is at a distance r. This is at a distance r. So this is the point where we are supposed to calculate the electric field, and the separation is 2a. So over here we can say that the charge per unit length lambda for the rod can be written as charge upon length, which is 2a. And over here at a distance x on this rod, we select an elemental patch dx which is having charge dq. So this is equal to dq by dx. So dq can be written as lambda times dx. So over here at this point we will be calculating electric field due to this length dx, which is at an angle theta, and at an angle theta it is subtending an angle d theta. So this angle is treated as d theta. So electric field due to this charge dq will be dE, and we will have two components of the field. One will be dE cos theta and the another will be dE sin theta. So the sin theta component will nullify itself because of the electric field which will be produced by the charges on the lower side of the wire. So the component on this side of the wire due to the lower charges will eventually cancel the electric field or dE sin theta part. So we can say that for the first part, the electric field at the point P, which we are considering this point, is going to be integration of dE cos theta. Now in order to evaluate this, we take E at this point P is equal to K charge dQ. So KQ by distance, so distance is r square plus x square, followed by this we have a cos theta part. So if we place this value, this one is lambda dx. So dq can be written as lambda dx kq by r square plus x square, which is this distance which we are considering, and then the cos theta component. So over here electric field at this point P can be written as, so now we need to put this value dx and theta in agreement with each other. So we are using substitution method. So for applying substitution method in this triangle, we are considering tan theta as equal to x by r, and therefore x can be written as r tan theta, and dx by d theta can be written as r sec square theta d theta. So we will use this value of x and this one value of dx to calculate the value of electric field due to the point P. So due to the point P we get k lambda. Dx can be written as r sec square theta d theta or cos theta d theta upon r square plus x square. So r square plus x square can be written as r square tan square theta and therefore at the point P we can write it as k lambda by r. 1 plus tan square theta is sec square theta and we are left with integration of cos theta d theta. Now over here the next thing which we need to understand is the limit of integration which will be needed. So the limit of integration will extend from the angle alpha to the angle again alpha on this side, since on both the sides the side length is a and r respectively. So over here I can say that the limit of integration extends from minus alpha to plus alpha, and on solving this we obtain EP equals 2k lambda by r sin alpha. Now what we do is we substitute the value of k lambda and sin alpha, and on substituting we get 2 by r. K can be written as 1 upon 4 pi epsilon naught. Lambda is charge q distributed over length 2a, and sin alpha is perpendicular a upon a square plus r square power half, or root over a square plus r square. And over here we obtain the final answer as q upon 4 pi epsilon naught r root over a square plus r square. So this is the final answer for the first part of the problem which we had. Now in the second part we need to calculate the electric field coinciding with the rod's direction. So the first thing that we do is we understand the diagrammatic arrangement of the situation. So to understand the diagrammatic arrangement of the situation, we consider something like this, that this is the rod. Now this rod is uniformly charged. This rod is uniformly charged, having length 2a. So this part of the rod is of length a, this part of the rod is of the length a, and we are asked to calculate electric field at a distance r from the center of the rod, say at this point which we regard as P. So over here we consider that if we consider an elemental charge length at a distance x, say here dx having a charge dq. So due to dq the electric field will be directed away and will have a value dE. So if we write expression for dE, so dE can be written as k q by x square. If we substitute the value, we have the value as 1 upon 4 pi epsilon naught. dq can be written as charge, that is dq can be written as q upon 2a multiplied by dx upon x square. So this is the expression which we have, and we integrate it. So from this part of the rod the separation is r minus a, and the farthest end of the rod will have a distance r plus a, and on solving this we obtain q upon 8 pi epsilon naught a integration of dx upon x square r minus a r plus a, and over here we obtain E equals q upon 8 pi epsilon naught a minus 1 by r plus a plus 1 by r minus a, and on solving we obtain it as q upon 4 pi epsilon naught r square minus a square. So this is the answer to the second part that we have. Now for both the part, the question is asking us to investigate the obtained expression for r greater than a. So we have already discussed this in previous problems as well. For r greater than a, both the system is going to behave like a point charge, and for a point charge the approximate result can be written as q upon 4 pi epsilon naught r square. This is for r greater than a. So these are the required answer which we have discussed for the problem number 3.13.